Very good. Well, welcome to our session today on maximizing PowerFX's potential. Today, our presenters are Kurt Reynolds and Tim Hanowich. They're both technology specialists serving our state and local government customers. And they are going to help you understand the full extensibility of PowerFX. PowerFX is the low-code language that is used across the Power Platform. And we're going to start off today explaining what PowerFX is. Then we'll move into its principles. And then lastly, we'll walk through some of its advanced capabilities and then a demonstration. And we do aim to provide a digital event today that respects all individuals. So we ask that everyone assist in providing that welcoming and safe environment. We provide 3 of these events to our customers each month. And so if you would like to recommend a topic that we touch on in the future, go ahead and drop that in the chat and I'll grab those and put them in our planning process. To minimize any distractions or potential background noise today, we're going to keep everyone on mute until the end of the presentation, and then we'll go ahead and open it up for live questions. So during the presentation, go ahead though and ask a question via the chat. We'll be monitoring that and getting everything answered for you that way. So don't hold your questions and forget them, post them there. So I'm going to go ahead now and hand this over to Kurt and Tim. Thank you so much for being our presenters today. Appreciate it.
Oh, my pleasure, Deb, and thank you for the great intro, and thank you all for being here today. So as Deb mentioned, we have a really cool session today on PowerFX, and I'll sort of cover off on the PowerFX introduction and some of the discussion, and then at the end, my colleague Kurt will show it live, working live. So we'll start first with what is PowerFX, and some of you might know what it is, some of you might have worked with it before, but really, all of us talk about, low code, no code, and we talk about building apps with Power Apps and building workflows with Power Automate, even building public web pages with Power Pages. But a lot of what we do, at least internally, of course, is Power Apps. And Power Apps, as you all know, very powerful tool, lets you build WYSIWYG applications, click, drag, resize, etc., like PowerPoint. But really, I think all of you understand that that's not quite enough, right? For an app to be functional, you need to have both the front end and you need to have sort of the background behind the scenes functionality, or a language, if you will, to allow you to program into it a level of behavior. And so what exactly do you need behind that application? Number one, you need, of course, a way to provide functionality. So you want your app to take in user input, interpret that, and with the user input, do something, whether it's submit data somewhere or pull data from somewhere and show it, etc. You also need a way to provide a level of user interface extensibility. So maybe you built your app with Power Apps and drag, but maybe you want to define a certain property of a control, for example, and maybe make it responsive, for example. And then thirdly, you also might want to do a little bit of customization around user experience, right? Not just how the app looks, but how it feels, and customize the way it transitions to a different screen, for example. Excuse me. Fourth, data management. All apps today, especially in the Power Platform, are about data, whether it's showing you data for reporting purposes, or whether it's about collecting data for Dataverse through the application itself. You need a way to actually describe how that data should both flow in and out of your app. And finally, it's not a very common use case, but sometimes your app needs to interact with the device peripherals, right? Maybe Wi-Fi, maybe your accelerometer and stuff like that. Again, not very common, but when you do need it, you need a way for your app to talk to the underlying device OS beneath the app to get from it data and stuff like that. So again, Power Apps' UI portion is fantastic. It's very extensible, and let's just truly build apps that are beautiful in the way that you'd build PowerPoint decks. But you need a little bit more to go one step further and to program, in quotes there, program the behavior of how the app should be working. So we need a little bit more. We need what's called PowerFX. We need an expressive language to allow us to program that behavior into our app, but that language PowerFX still also has to be low code, right? As part of the platform. And with the prefix power, it has to be intuitive and easy to use. So today we have that called PowerFX. Let's talk about sort of where it came from though, right? And I think its evolution will sort of give you an idea for how it's designed. So when we said to ourselves, okay, we want to design a, a language behind Power Apps to allow developers to program behavior, it's part of the platform. We want it to be intuitive. Where do we start exactly? And the answer to the question, actually, we found here internally. So I'm going to take you all the way back to 1985 when Microsoft and Bill Gates at the time introduced Excel, right? First came to actually the Apple Macintosh, not a Windows machine, but Excel was a spreadsheet program that, similar to Power Apps, right, would let you build a product or a spreadsheet in a visually appealing, intuitive manner. Again, not really app development, but it is a parallel to designing a product in that you customize your own UI, and then you'd use sort of like this no-code, low-code language within the UI itself to customize and describe the content or the value of a cell or multiple cells within that spreadsheet. Again, not exactly app development, but very similar. And this concept we introduced here in 85, and as you all know, since then, it's caught on quite a bit. And today Excel, I mean, literally almost 40 years later in 2024 now, it's one of our most successful offerings that we have here at Microsoft. And on the left, you'll see there the meme that the whole world's economy is built on Excel almost. And we estimate that globally, 1.1 billion people use Excel. So it truly is not just for us, but in general, it's one of the most successful applications in the world. And today, you know, you've seen, I'm sure, AI infused into it. But the reality is the core spreadsheet experience is mostly unchanged. You know, the core experience of defining cells and their value with simple language is it's still there. So it's clear to us that this concept of having this low code, if you will, syntax or language to define the property or the value of a cell based upon other cell values and also a combination of that and the user's intent, it caught on pretty well. It's intuitive, and it's so intuitive that 40 years on, 1.1 billion people around the world use Excel regularly. And so when it came to Power FX and Power Apps, we thought, why not take advantage of the fact that so many people around the world are already familiar with Excel, and so many people, like myself, for example, grew up using Excel, and we learned it at a young age. And for us, it's simply intuitive to use. And so we thought, why not build Power FX and Power Apps around or sort of loosely tied to the way that Excel works? And so that's why when we first bring people to Power Apps and we talk about app development and the way to, if you will, program it, the first principle in place is think spreadsheet, right? Again, all of us are accustomed to Excel. We all understand the sum function, you know, equals sum, the count function, average, min, max, even a simple developer concept, right? The if statement, if else, and so forth. And so we wanted to roughly emulate the way Excel does it in Power Apps and Power FX. So on the right-hand side there, the top right, what I have is a simple example showing string, right, text manipulation within Excel with a write function, a find function, and so forth. And the bottom right, I have the same exact formula, the same exact function written for Power FX. And you'll see here that, again, they're meant to be very, very, very similar, almost no difference whatsoever. And so oftentimes when you first come to Power Apps, think about Excel, you know, and almost pretend as if you're trying to enter in a syntax or a value like you are in Excel, and that same knowledge time now in Excel can oftentimes be ported over to Power FX with maybe, if needed, a minimal change. But again, the first property of Excel, the first principle of Power FX is to think spreadsheet, think Excel. So next up, Another key principle here with Power FX is that it's always live. So take, for example, what I have here at the top. So I have 3 sliders in an app, one for red, one green, and one blue. And I'm setting the RGB value of the background screen equal to the combination of the red, green, and blue sliders. So of course, as you scale one up or down, it'll change the background accordingly. Well, I think you'll appreciate this, but in Pro code, whatever you use, .NET, Java, Python, React, Angular, UWP, whatever it might be for you, oftentimes the way that we'd look at that is we'd say, okay, there's 3 sliders here, and each slider, I want to change the background color upon that value changing. So oftentimes the control will give you sort of like this on change event, and you can subscribe a pre-built function to trigger upon that event happening. So you'd probably go in there, you would build your, modular render or your refresh interface function, and then you would subscribe that to the on change event for both the red, green, and blue slider. And so that might be a little bit complicated. The cool thing here is in Power Apps and low code, and by the way, actually this is a Power Apps example, it's meant to be a little bit different through Power FX. It's meant to be always live. So what I have here, you'll see is at the top there in the fill bar, I'm setting the fill color equal to the RGB calculation of number 1, the red value slider, green, and the blue slider. And you'll see here, that's all I've done. I'm not subscribing to an on-change event. I'm simply setting the fill value, and behind the scenes for me, Power Apps and Power FX automatically understand that you want, my intent as a developer is to re-render and recalculate that background color upon one or multiple of them changing. So think of this, that you think of always live. You don't have to worry about events and rendering and the UI thread and the background thread. It's meant to be very intuitive to use. Thirdly, data IO. Again, I mentioned before, but today everything's about data, and Power Platform especially is all about data collection and data reporting. And today there's so many places to put data, right? We have SQL, we have Dataverse, Oracle, SharePoint, and many, many more. But the challenge, of course, is oftentimes a developer, if you want to use SQL in your app, you'd have to understand how to use SQL in your app. If you want to use Dataverse, you have to know how to use Dataverse in your app and so forth. Each database oftentimes has a either somewhat common but also somewhat proprietary way of both pushing data to it and pulling data from it. So the challenge here, again, for a developer is understanding exactly how to do that. One way we're trying to mitigate that challenge with low code is by providing to you through Power FX essentially an abstraction layer of database querying tools. So in Power FX and Power Apps, when you want to, for example, work with data and you want to filter, you will use the filter function or lookup or search and so forth. The cool thing here is don't think that through Power Platform, you have to learn each individual unique data source. Rather, you have to learn the abstraction layer, the filters, the lookups, search, sorts, tops, and so forth. And once you learn that, the actual translation of your intent in that abstraction layer is translated by Power FX, by Power Apps into the data source that you have of choice, whether it's SQL, Oracle, or whatever. So really, again, think here that in Power FX, no need to worry about SQL or Oracle and difference to them. Is it SQL or MySQL? Simply put, you can work with a common layer of data IO tools, and that layer can be applied across the entire data sources available in the Power Platform. So, for example, what I have here is a screenshot showing you, simple gallery for an accounts table. I have my gallery here using the accounts table in Dataverse. In theory, right, if I completely severed that connection and I instead hooked it up against an accounts table in SQL, as long as my tables are the same names, same columns, the same thing it'll just simply work. I don't have to translate from using Dataverse through OData through an API to SQL. It's just meant to simply work. So it's, again, one single layer of language to work with any data. Also today, about data, it's not only is there tons of data out there, but also, as you all know, through Dataverse and so forth, data is oftentimes relational. And I'm sure what I have here is not uncommon or new to you. It's an ERD, an entity relationship diagram, and it shows the relationship between tables here. And again, oftentimes in an app, you're going to have to traverse table relationships. You'll have to traverse, one-to-ones, one-to-manys, many-to-manys, and so forth. And that can be challenging. So for example, if you wanted to in SQL, you'd have to understand join operations. And I don't like join operations. They're not fun, but I do use them, of course, for my apps. When I do, oftentimes I'm going to, Bing online to search for how to do a join operation or to refresh myself, maybe ChatGPT too to learn how to do that. But I'm simply trying to figure out how to hack together a proper join operation in SQL. Or if your data is in Dataverse, or if it's in another third-party API system, like a REST API, easy, it's good to use that, but it's not the easiest to use that. So to do a join operation, you'd have to oftentimes use the expand query and specify exactly what table to expand to and what properties you want from the table and so forth. It could be challenging to do individual queries like this. The very cool thing here, this is probably my favorite part of Power FX, is just how easy it is and how natural it is to literally reach across a table boundary to another related table and to pull content in accordingly. So, for example, what I have here is a video showing you, I have the accounts table in there. I'm going to reference the first record in my accounts table, and then I do dot primary contact. The primary contact is a lookup to another table called contacts, essentially, a foreign key here, of course. When I use the dot notation, you'll see here, when I plug in primary contact, the system will understand I'm trying to reference data in the contacts table because the primary contact column is a lookup to that table. So on the left there, you'll see here, it'll add in for me that contacts table. And then from there, again, I'm able to proceed, use dot notation, and reference the full name property of that table. So again, I'm not doing join operations. I'm not doing lookups. I'm not using foreign keys either. I'm simply delegating to the system itself to understand my intent to traverse across relationships that, and it pulls in, it ties in the contacts table to my app, and then proceeds to simply let me reference properties in that table via dot notation. Very intuitive, saves me tons of time. For me personally, comparing pro code to low code, this is probably the most compelling part of it, at least a small table of it, at least. Also, Power FX is designed to be very efficient. So what I mean by that is efficient in terms of speed, but also bandwidth. So take, for example, what I have here. I'm referencing an employee from the employee table, excuse me, from the orders table, and I'm referencing the employee property that I'm pulling from that, the first name column. That's simply all I'm doing. You might already know this, but when you use Power FX, what happens is Power FX, excuse me, when you use Power FX to call in data from a table, Power FX will scan your entire app and it will understand what data is needed from that table and when. What I mean by that is what columns are needed exactly. So here, for example, when I'm referencing only the first name, in a pro code app, you'd have to, like a SQL, for example, you'd have to specifically select only the column that you want. And oftentimes that can be exhausting. Some people just use the star, symbol to pull in all data, but Power FX won't do that. It'll know based upon your request, and for that matter, the entirety of the use of that table and the whole app itself. It'll know that you only need the first name column here. So it'll specifically do a request to your data source, Dataverse, wherever it might be, for only that property to save bandwidth and to save time ultimately, to make things more efficient. And then secondly, earlier I showed you the RGB screen, that simple example of the live property being changed for that background color. What's cool here is, again, it knows to only calculate that upon the slider happening. So it's not doing some, once per second change of this or to recalculate the RGB value, but rather it knows to only do that, number one, when it's being shown, and number two, when it's being changed. So natively, naturally, PowerFX is designed to be as efficient as possible. So moving on, I do want to call out a few cool things here about PowerFX, and maybe some of you as developers will also appreciate this, but PowerFX, in case you don't know, is actually fully open source. You can go right now to GitHub and search for PowerFX under the Microsoft account. You'll see that the entire code base is completely open source. It's all there for you to use. It's a .NET based project. And if you're curious and if you want to see the most up-to-date stuff, it's all there. And sometimes, I do it myself sometimes too, you can go in there, you can find some, maybe a new PR, for example, which will show you a new upcoming feature for PowerFX and so forth. And so very cool. And as such, with it being open source, not only do we provide to you the code base behind it, we actually encourage you to use it if you want to in your own applications. And we actually package it up for you and release that on NuGet. And if you wanted to, you could literally install this into your app and use the PowerFX core, solution through REPL or whatnot to provide functionality in your app. So I just think it's super cool that the whole Power Platform, a commercial offering, we've literally released a part of it as open source if you want to see the code there itself, and also if you wanted to use in your own projects out there. So at this point, I want to go more into specific, what I would call advanced abilities of PowerFX. And some of these Kurt will show later on in just a moment or two here. But the first one I want to touch on here is the parse JSON function. So JSON, JSON, it's JavaScript object notation. Simply put, for those that do not know, it's a way to serialize data for a table or a record, for example, or whatever it might be, into a string. So JSON is a very common format today. It's the way oftentimes that modern day APIs will talk to one another. They'll exchange data via JSON. And JSON is super common today, and pretty much every app has to be able to read, parse, and construct JSON to some extent, at least some most of the time. Up until recently being late 2022, Power Apps could not parse JSON. Maybe some of you here know, but if you wanted to, you would have to do that through Power Automate, because Power Automate could do it. So oftentimes people would build Power Apps and they'd have Power Apps delegate to a Power Automate workflow. Here's JSON, parse it for me, give me back this property, return back to Power Apps accordingly. Now it's actually available to use in Power Apps. So we have the parse JSON function, which will return back to you what's called an untyped object, which you can use to then show that data in your app. Also, number two, string interpolation. A big word there, interpolation, but it's actually a very simple concept. It's actually one borrowed from .NET for that matter. And, on the right there, for example, some of you probably know you can concatenate a string, right? Combine text with text together with a plus symbol if you wanted to in C# and .NET, or in Power Apps with an ampersand symbol. Or if you wanted to, what would probably be a little bit easier is what I have here, right? Take the first one, concatenation, versus what's probably easier is to simply write your string and then in brackets, enter in the variable name and allow PowerFX for you to insert that string into your bigger string. So, not really in any way groundbreaking, but it just shows that we're bringing more of the pro code familiar tool sets available to you here in PowerFX. Also, we have user-defined functions, also a very common question now solved in preview. but I'll bring you back here, I'm sure, to maybe a formal coding class you've been in the past, but two key concepts in development, right? Number one, modularity. Take a big system and try your best to go down, break it into smaller, independent components, right? To allow you to pinpoint bottlenecks and errors and to scale ultimately. And then number two, reuse and reusability. You know, once you have modularity, build consistent, reliable parts of your app that can then be reused through your app or even other apps for that matter. Oftentimes people asked us in Power Apps, how can I build a reusable function, in Power Apps? How can I reuse that throughout my entire app? You could kind of do it before with a simple hack or two. It wasn't perfect. It was sort of a way to work around, if you will. But now we have an in-preview feature called user-defined functions, or UDFs for short. And UDFs allow you to define a function or a def in Python, for example, whatever it be for you in your language, but it allows you to define, here's a function, here's what it does. The function has parameters, maybe one number, for example, one string value, and it has this return value back to the user. So it allows you to actually define your own functions and Power FX in the app, and then reuse those throughout the entire app itself. Also, a very important concept here in development is error handling. Been around now forever, almost. In .NET, you have try, catch. JavaScript, again, try, catch, Python, try, and accept. But whatever you use, I'm sure it's out there to handle errors. And this is a key concept as well in Excel. And again, in Power FX, we want to emulate Excel. So we also have the if error function, allowing you to very easily say, if this calculation does not produce an error, give this. If there is an error instead, show this to the user. So essentially to handle an error and based upon that, prompt the user in a certain way. And then finally, again, I mentioned before, it's not very common, but some apps need to access device telemetry. So on the left here, what I have is I checked the code required, the boilerplate code required to use an on-device accelerometer in both an Android phone and an iOS device. And you'll see here, it's not the simplest thing to do, really. It does require a level of expertise to do this. And then also at that point too, you're also platform dependent. What would be great is what we have here with Power Platform, again, your Power App, which you'd make your Power App, and then you'd say, okay, now I want to embed telemetry from my device into my Power App. What would be ideal is if you take your Power App, reference a standard layer or a standard function or standard module, if you will, in Power FX, and then Power FX will interpret what you want and translate that and work directly with the device OS beneath it through the Power Apps player, of course, whether it's Android, Apple or Windows, and use those to interact with and pull data from the device's accelerometer, compass, location with GPS, or Wi-Fi connection. So again, with Power Apps and Power FX, don't think you have to understand how to use the Android SDK or iOS SDK to pull data from your app for your gyro, for example. Simply put, you can use Power FX as the abstraction language and allow Power Apps and Power FX for you to take your intent, your request, and then work with the underlying device to pull data and give it to you in Power Apps as you requested it. So with that being said, I'm going to stop there. I'm going to stop sharing, and I'll turn it over to Kurt to show you a live demo we just discussed.
All right, thank you very much, Tim. Appreciate that. Tim always has some amazing insights to how the Power Platform works. So I'm going to share my screen, and yeah, I really do appreciate that, Tim. So starting out, we're going to go through today a few topics that Tim discussed. I don't think we'll get through all of them. We're going to start out using parse JSON as our core, and while we're talking about parse JSON, we'll also be talking about string interpolation, error handling, and actually interacting with Power Automate and an API. So that's the core of what I'm going to try to show you today. We're going to start out slow, then we're going to crawl, and then we're going to run. So we're going to start out today in one of my training environments. This is a government cloud environment. So if there's anything you see here, it should be reproducible in the government cloud. I have a solution created today for PowerFX training. And we're just going to start out by creating a Canvas app and then throwing some stuff on the Canvas app to demonstrate some of the different functionality that we're talking about. So we'll go in here and we'll go into new Canvas app. PowerFX 25 April 2024. All of this is being done live. I like to, I really do like, the fun part is about this is doing things live. So I'm going to, Tim talked about the if error function. There's also another place where we can do error handling, and that's at the app level. We can go into the app level and on error and have a persistent error handling throughout our application. So I'm going to throw something in the on error function here. If anything errors while we're working today, maybe we'll see that. So we're going to use the notify function. And if we get an error, we're going to notify ourselves. We use string concatenation. Haven't talked about that a bit. And we'll pick up the first error, which will, and we'll get the message, and we'll display that. And then we'll also go, we also have access to the component. For the source of the error. So we'll close out that. So this is another way to interject error handling into your application. If something should happen, we'll use the notify function and we'll post a message that has the indication that an error has been received. The error message should be posted, and then the error came from, it'll show us the source of the message. So I don't have any built-in errors into the application today, but that's where we're going to start. So I'm going to rename this screen to JSON demo 1. We're going to start out by talking about JSON as Tim did, and we're going to do some parse JSON operations. So we're going to, see, I'm going to change the background color of our screen. We'll change this one to light blue. And I'm going to pull up, Visual Studio Code real quick and show you that the JSON that we're going to be working with. We're going to get into way more complex JSON and API interaction later, but we're going to start out with a straightforward JSON object. And this particular object has a key value pair inside of it. It's only, I guess, one object if you look at it like that. There's a name, an email, years on board, and active. Now, Tim talked a little bit about untyped objects, and some of you may know this already, but if you don't, Power Apps is a strongly typed application, but the parse JSON function allows us to deal with untyped objects. In this case, you can see in the JSON, we have a text object annotated by the fact that it's entered in quotes or a string. We have the email is entered as a string, but you'll notice down here, we have years on board at 25, and that's not inside of quotes. So that's indicated as a number. I also put something in here very popular in Dataverse anyway to have active and inactive context. and I put true in here. This is neither a string nor a number. This is a Boolean, and this would be evaluated as true false. So when we retrieve this stuff using parse JSON, not only do we need to know the structure of our JSON, but we need to know the type of these objects, because that is not going to be available inside of the system until we type it ourselves. So the first thing we're going to do here is we're going to throw an input box on the screen. I'm going to change the font size of the information that's being displayed. Left. I'm going to change it to multi-line. And this is where we're going to put our JSON object. We're going to put a label on the screen, and this is where we're going to extract information from that. And we'll change the I don't know if that'll be okay. We will change the font though, so it's a little bit more visible. Okay, we're good. Okay, so I'm going to go over and copy the JSON that we were talking about. And I'm going to put it into our text input field. And now you'll see that we have our JSON. What we're going to do is we're going to use this text field to extract the name, years on board, and active from this JSON. And this is just our starting point. So we're going to start up here with the text property of our label. We're going to type in parse JSON. And so parse JSON takes an input, and it takes a string or text object. So the parse JSON, we're going to get this JSON from our text input. Text. Okay. And you'll see that the parse JSON function is attaching itself to text input.text, which is this object here, and it has identified the fact that this is an untyped object. So we do need to know the structure of our JSON to get the information out of it. It is case sensitive and has to be spelled correctly. So now that we have the text, parse JSON function can recognize things like name, email, years on board, and active. It doesn't know the data type, but it does know that it exists. So I'm going to type name. You'll immediately see that it recognizes, okay, name, Kurt, and it puts it in the field down here, which is what we're doing, but it still doesn't know what sort of type it is. And you'll notice in the explanation underneath of it, it says untyped, that we should use value, text, or other functions to establish the type. So we're going to use the text function here. And we're going to wrap this field in the text function. And now you'll see our untyped object goes away, and it immediately knows that out of this JSON, it pulled out the name from the name key, and the value is Kurt, and it knows it's a text object. This typing is important because if you're going to use it in a patch function, or you're going to use it somewhere else in your application, it needs to be correctly typed. Now I'm going to paste this down here, and we're going to grab the, I don't know, let's grab years on board. And again, we have to spell it correctly, and there is no IntelliSense. I'm trying to be very careful to type it correctly. And we'll, that's not going to be a text object. Let me get rid of this. Okay. And once we get the function written correctly, the parse JSON object again, it takes the text input, it understands the structure, but it doesn't know what type of object it is. Again, we can use value, text, or something of that sort. We know that it's a number. We have to know our JSON structure ahead of time. And so we're going to wrap this in a function of value, which will allow us to properly type this input and types it as a number. So you can see here that using parse JSON, we can send a text input, and then we can type the object coming out. Parse JSON can also be used for, one thing I forgot to do was save my app. I'm going to save the app in the other right. Parse JSON can also be used to interpolate arrays. I'm not going to go through that because I don't think we have time, but let me pull up my, actually this is Notepad++. This is an array, and we can use parse JSON to attach to this array, and we can pull out information from this array. Spring, summer, winter, fall. We could use parse JSON to do that. And again, I just don't think we have time to do that. I've got some more complex examples I want to get to, but just be advised that you can also use it for arrays in your application. All right. Next thing we're going to do is we're going to create a screen, and we're going to use an API that's available publicly to pull back some complex information. And then we're going to use parse JSON to parse that information. So again, we're going to color the screen in a light coral. How about that? Okay. The API we're going to be using, we're going to rename this to Swappy. You may have heard this before. Swappy stands for Star Wars API. And I'm going to show you real quick what an API call looks like to Star Wars API and how we're going to get that data. So you can search for Star Wars API on the internet, and you'll see here that there's an API that's publicly available, doesn't require authentication, and we can make an API call, and it will give us back JSON information that we can use in our application. It also tells you here, in this example, you could go to the documentation and get the same information, but you can see the API call that's being made. So if we went to planets, for example, this is planet information from Star Wars. This is Yavin 4. I don't know much about Star Wars, but that's what it is. And this is the URL that you would use for that. I'm going to throw that into a Notepad file so we can analyze the JSON when it comes back. And now we're just going to use planets 1. And if we have time, we're going to get to an example where we just pull back planets. So back over to our Power App. And the way we're going to call this API is by using Power Automate. I'm not going to go through building a Power Automate function today, but I will show you how the Power Automate is being called and how the information is being passed back. So first, I have a Power Automate in my solution, but it's not in this application yet. So I'm going to add it to my application. And I called it the Swappy API, standing for Star Wars API. And so here's the Swappy API flow, which I built earlier. It's a very straightforward or simple flow. If we go into edit, if you don't know this, I'll do a quick explanation of how you call a flow from a Canvas application. First off, the flow is a instant flow. And the trigger that we would use for in Dataverse or a SharePoint flow, the trigger is the Power App V2 trigger. If I click on the V2 trigger, it can take various inputs. It can take text input, yes, no inputs, so forth and so on. Today, we're just going to take one input, and that input's going to go here when we call this API or this Power Automate. We're going to take that input, and we're going to put it into an HTTP request action. It's a GET request, and I got that from the Star Wars API documentation. Requires no authentication, so that's all we're going to do there. From the body of the HTTP request, we're going to create a variable called return data. It's not necessary to put it in a variable, but I put it in a variable because I think it makes it more straightforward and easier to understand. And then the last step of getting the information back to our Canvas app is to respond to the Power Apper flow. So the first and the last are built in. And if you're building your own flow, it would just be everything in the middle that would vary from this example. This flow only has one response, and it's called an API return, and it's returning this variable called return data. So that's how we're going to get from our Power Canvas app to an HTTP request, getting the body of the request, to sending it back to our app. So we didn't make any changes, so we're just going to go back to our application. So the way we're going to call this is we're going to put a button on the screen. First thing I'm going to do is put a text label on the screen. And inside of this text label, I'm going to put the URL that we're going to call, just so that I don't have to keep going back and forth between Notepad. So I'm going to put that URL in here. And we'll change the font here so you can see that. So this is the URL that we need to pass to our API. We're also going to put a text input box on the screen. And this text input box is going to be where we store the information that comes back from the API call. Again, we'll change the font on this to 22. We'll change it to multi-line. And I think that'll be good there. Okay, so we got input and we got a text box. Now we're going to add a button so we can call our Power Automate and get some JSON data back. So we'll click on button. And we'll just say this is going to be to get floppy data. And I guess I should change the color of it. I guess that's okay. And again, we'll change the font size. Let's choose 34. And we'll make that a little bit too. So what we're going to do with our button is on select, we're going to call our Power Automate function. And when we call that Power Automate function, we're going to put that into this text box. And then we're going to use the information that's in the text box and use parse JSON. So we're covering a load of concepts here. So we'll go to on select. And the first thing we have to do in on select is if we type in the Swappy API, you'll see that the Power Automate function is there. And we need to do .run. Right? We know from our definition that the run takes a text input. Oh, hang on, we're going to back up. I got ahead of myself. Let's put another text input field here so that we can input our URL. My fault. I really got ahead of myself there. And in this text input field, I will use that to call the Power Automate. Sorry. So we're going to run. And what we're going to be running here is the text input 3. And we're going to get the text from text input 3. And now it's going to look at the Power Automate and it's going to give us options. And our Power Automate only has one return, and that's called APR return. So that would technically go get the information. And we could put that directly into this text input box. But what I'm going to do is I'm going to wrap this in a set function. And we're going to set a variable. And let's call this swappy data. And we're going to put the swappy data, we're going to assign whatever comes from that API return into the swappy data. So this button is going to go get the data. It's going to put it in this box. Let's go test that out. And then after we test that out, then we'll go work with our parse JSON again. So we'll play our app, text input. Type the data in. You'll see the little dots going across the top of the screen. Well, that doesn't look good. All right, let's go back and make sure we have the right text input 3. Oh, there we go. So when we get the data back, we need to show it in the text input so we can see it. My bad there. So text input, the text for this is going to be swappy data. And there you go. So I apologize. So we can go back and run it again. We can actually play around with this a little bit. If we took the 1 off of the end, we went to get swappy data, it would go get all the planets. And in this particular case, it's just going to get planet 1. And planet 1 is Tatooine, I believe is how you say it. And we'll close that off. So now we're going to use parse JSON, and we're going to get the information from this JSON. So I'm going to go back to the Visual Studio Code. It actually looks like this may very well be the last one we're able to get to. So in the JSON that comes back, this JSON has multi-levels. So you can see that we have at the message level, and then we have results, properties. And to get any of the properties like diameter, rotation period, or any of that information, we have to go one more level down to name. And again, you have to know this ahead of time. There is no IntelliSense when we're working with parse JSON. So we'll put a text label on the form here, and we'll see if we can get the name of this planet. And we'll say that the text is going to be parse JSON. We got to pass in our swappy data. Now that we have our swappy data, still an untyped object, we need to get the result, properties, name. And you can see that it gets the name right off the bat, and it also puts that in a, it tells us it's untyped. And we'll wrap that in text, and now our untyped error goes away, and it understands that this object is a text object. So there's other information inside of there. I'll copy this and paste it. If we just look at the JSON, we can see that there's a lot of other information in here. Most of it is textual information. There's also information up here at the top, the message, which is okay. But for example, we could get the climate from that using the same structure. So if we go name, just change this to climate. Then we get the area structure right there. So I think we got about 3 more minutes. I don't know that we have time to do any more information. I will talk through this, the other example I was going to show you, because we are talking about intercepting information from an API. If our API returns to us an array, then this is what it will look like in the JSON. It will be wrapped in square brackets. And if we wrapped it in square brackets, then we have a bunch of objects inside of our array, and we could actually see that information. So I don't believe we have time to do that, but we would use the same parse JSON. We would point it to our text object, and we would get dot results, and then dot results. Actually, we probably have time to do that. Let's change this. Let's play this. Let's see if we can do this. Let's go back and get planets. We'll go get sloppy data. It's going to get the planets. Now that we have the planets in there, we're going to, let's create a gallery. We'll close this out. And we're going to say that the items in our gallery, we'll go gallery 1. The items in our gallery are going to be parse JSON, and we're going to be parsing our sloppy data. And when we parse the sloppy data, we're going to be getting the results. And this is not a text or a number. This is a table. And so then that gives us a data source that it understands as a table. And now if we changed our gallery, let's go check on the gallery. We're going to change it to just title. And then let's go in and set the title of one of our objects. And when we set the title here, it's going to be this item dot value. So the value of that item dot name, and you'll see that it gets the name of the plan and it puts it in the grid. So Tim, I think that's about all I have. We're going to wrap this in text. And if you want to wrap it up for us, that will be awesome.
Yep, Deb, I'll pass it over to you for closing.
Fantastic. Thank you, everyone. I put a link to a survey in the chat. If you could please give us feedback, that would be great. I also posted our upcoming sessions. If you scroll up to a little bit, you'll see those there. Our next session will be on May 16th, building your own controls, reusable components. And thank you so much, Kurt and Tim, and have a beautiful day. Thank you.
Bye-bye.